This is Mod 0 Day 6. We're going to keep talking about functions that you guys have seen before. We did linear functions, we did quadratic functions, and now we're going to talk about exponential functions. Now you've actually only done a tiny bit with these. You guys are going to talk more about them actually in the second half of this class. When you take up applications of functions 2, you'll talk more about exponentials. But for now I just want to review what we've learned before, just a little bit about their graphs. And basically an exponential function is when the variable is the exponent. So instead of, remember our quadratic functions had an x squared in it, if you switch the 2 and the x, you get an exponential function. So instead of x to the second power, or x squared, you have 2 to the x power. And as soon as that variable x becomes the exponent, you get what we call an exponential function. So we're going to focus on two different types of exponential functions. And to differentiate between the two, I'm going to give you a vocab word. The number that's being raised to the x power is called the base. So like in my example from before, when we had 2 to the x, 2 is the base. If we had 5 to the x, 5 would be the base. Now, when the base is bigger than 1, any number at all bigger than 1, you get what's called exponential growth, because your function is growing bigger and bigger and bigger. And an exponential growth function is going to look something like this. In fact, this right here actually is a graph of 2 to the x. So you have this function where if you look at it on the left-hand side, it's almost 0. It's almost pressed into the x-axis. And then it starts growing, and at first it grows very slowly, up a tiny bit, a tiny bit, a tiny bit, but then all of a sudden it's bigger and bigger and bigger. And if you look at the end on the right side, it's going almost straight up in the air. It's growing very, very fast. And that's what an exponential growth does. It has that nice smooth curve where it's kind of flat on one side, but then it turns very steeply up on the other side. Now the other type of exponential function is called exponential decay. And decay is the opposite of growth. To grow means to get bigger, to decay means to shrink or get smaller. So that happens when the base is less than 1. It's usually either a fraction like 1/2 or a decimal like 0.7. And what you get is a mirror image. It looks the same, but instead of being flat on the left-hand side and going up on the right-hand side, it's flat on the right-hand side and it's going up on the left-hand side. So the reason we call it decay instead of growth, when you're talking about a graph, you're usually thinking of a point moving along that graph, and the point is always moving from left to right. So if the point starts right here and starts moving along the graph, it's getting smaller. It's moving downward on the graph, and to move up on a graph means to get bigger, and to move down means to get smaller. So this is exponential decay. It's just going to keep getting smaller and smaller and smaller and closer and closer and closer to 0. It kind of squeezes into that x-axis. So that's the difference between exponential growth and exponential decay. And to really give you an example of exponential growth, here's a little kind of a riddle for you guys. So let's say you're offered 2 jobs to work for the next 30 days, to work for a month. And the first job says, if you work for me for 30 days, I'll give you $10,000, which is a lot of money. And the second job says, well, if you work for me for 30 days, I'll give you a penny the first day you work, and then after that, I'll just double your money every day. So I said, which job would you take? And you guys can think about it. Do you want to take that penny and double it and see how big it gets after 30 days? Or do you just want to take the 10,000 and be like, that's a lot of money, I'll take it? Well, if you start thinking about it, you think, okay, well, I work for 1 day and I have a penny. That's nothing. I work for 2 days, I have 2 cents. 3 days, I double that, I have 4 cents. And then 8 cents, and then 16, and then 32, and then 64. And then finally, on the 7th day, you have $1.28. It took me a whole week to get just $1. And you're thinking, well, it took me a week to get $1. 30 days isn't going to get me much. I'm taking the $10,000. Well, if you had taken the job number 2, in 30 days it pays over $5 million. And that's an example of exponential growth. I want you to realize that exponential growth grows very slowly at first. 1 cent, 2 cents, 4 cents, 8 cents. You know, we still have almost nothing after a week. But if you wait long enough, it grows faster and faster and faster until pretty soon it's growing very, very, very fast. So the graph of that second job looks something like this. You know, right here on this flat part, it's a little bit messy. Right here on the flat part is where you're barely increasing at all. That's where you go from 1 cent to 2 cents to 4 cents to 8 cents. I still have nothing. But eventually, all of a sudden, you have $1, and then $2, then you have $100, and then double that, and it's $200, and you have $1,000, double that, it's $2,000. So when the amount starts getting bigger and you're doubling it, all of a sudden it gets a lot bigger. And that's the one thing I want you to remember about exponential functions. They grow very slow at first, but eventually they grow very, very fast.